Today we're going to look at Chapter 2-10 and look at air quality monitoring and how it's reported. So, depending on where you live, you breathe air of varying quality. So, some locations around the world just always have healthy air. Some of them have kind of okay air, and then some have like really bad air most of the time. A lot of these differences come from a bunch of factors like population. If there's a large population center, it's really hard to have good air quality. Regional activities. Some areas rely heavily on coal-fired power plants, so you get a lot of that kind of pollution. Geographical features. Let's say you live in a city that is nestled snug amongst a bunch of mountains that kind of trap that air in, or even like weather patterns. So you might live in a big city, but because of weather patterns, the wind is always blowing the bad air out. And then, of course, like what activities are going on. So if you live in a country where there's a lot of reliance on coal to power your homes or to be able to do cooking, you're going to see a lot of really poor air quality. Now, to get better air quality, every single country in the world has some kind of legislation. In the United States, we have the Clean Air Act from 1970. This is the very first act that really established air quality standards. And what they were focused on was limiting our exposure to hazardous substances. So it's called a command and control law, or end of pipe solution, because the U.S. Clean Air Act is really like, all right, what happens as it comes out of the pipe? How do we limit that spread? And how do we make sure that the impacts are not bad? Now, in 1990, before any of you were born, the United States passed a second act called the Pollution Prevention Act. Now, this is a really interesting act because rather than being focused on where we're doing is cleaning up the end of the pipe, it's actually focused on preventing the formation of hazardous substances. And so the whole act is pollution should be prevented or reduced at the source whenever feasible. And it was a whole big shift in how legislation looked at air quality. And so with the Pollution Prevention Act, it became national policy to employ practices that reduce or literally eliminate pollutants as their air source. Thanks to increased education about air quality and also the implementation of things like the Pollution Prevention Act, there has been a dramatically decrease of the concentration of air pollutants in the United States since the 2000s. Now, it's not just laws and regulations that done that. For example, local communities will have an investment in wanting to lower certain pollutants to clean up air quality. Companies will implement certain measures to not only improve air quality, but maybe also improve different chemistry processes they're doing. And then chemists, of course, have green chemistry, which we'll talk about later, which has implementation of different procedures and policies that help clean up different types of pollution. Now, even though air quality has improved, people in some metropolitan areas, though, still breathe pretty unhealthy levels of air pollutants. So the way we look at that is like this. So you can measure different levels of concentrations of different pollutants in different cities. So this is Boston, Chicago, Cleveland, Houston, LA, Phoenix, Pittsburgh, Sacramento, Seattle, and Washington, D.C. Now, even though air quality has improved, what do you see there? So like Chicago had 10 days where they had really bad ozone, and Los Angeles had 43 days. Whereas in PM, like Sacramento had 13 days where PM 2.5 was so high, it was considered hazardous. To help with understanding unhealthy air in cities, the EPA developed something called the Air Quality Index, AQI. And this is in the example of the Air Quality Index. And what it does is it's scaled from 1 to 500 with a value of 100 pegged to the national standard. So think of it as an adjustment to take into account that different pollutants have different standards. So when the AQI is between 0 and 50, your air quality is good. And you have a bright, happy green color because green means breathe good. When it's between 51 and 100, it's moderate. So it's a yellow color. So there's some warning, you're seeing some levels of higher pollutants. Now, when you're at 101 to 150, it would be unhealthy for sensitive groups. That would be people with asthma, older people, infants. It's orange. If you get above 150, you're unhealthy. If you get above 200, very unhealthy. And of course, if you're in the 300 to 500 range, you are considered hazardous. So these different standards are used as a way to visually represent to people in the public the air quality for the day. And we use them even in the Portland area. So when you're watching the news, sometimes you can see in the news, especially like when it's fire season, they'll show a color and say the AQI or the air quality index for the day is considered red or even maroon. It's hazardous to your health. So here's an example of Phoenix, Arizona. This was in 2015 to 2016. This was over New Year's Eve and New Year's Day. And there was variations in the patterns. And there was actually also, when you see that really high PM 2.5 on Friday, January 1st, that's actually a result of local activities, including fireworks and then also a fire. So it's kind of fun. You can see that impact. So each day the ozone is green, so it's pretty good. But you see an increase in PM on the Thursday the 31st and then on the 1st, and then you start to see it clean up when you get towards the 2nd. So the pollution of concern was that PM 2.5, and that really was from, like I said, the wood smoke and then fireworks. And so if you were outside, they advised you to do not ride your bikes, to not go jogging and things like that, and to actually limit your outdoor air time, because you can see it's that maroon color. It was really bad.